Hi and welcome to E-ZTutoring. Today we're going to cover how to graph a hyperbola. So a hyperbola will follow the form of x minus h squared over a squared minus y minus k squared over b squared equals 1. Now there are two cases for hyperbolas. One of the cases is like this, and the other case is very similar except for the fact that y comes first and y is over a squared. So the only difference between these two hyperbolas is that one will be, where should I write this? Vertical, and this one will be horizontal. So it is definitely good to be familiar with both of these forms, as both of these forms follow different rules. So the first thing we're going to need when graphing a hyperbola is your center. Your center is at the coordinates h, k. Now this is the same thing for a horizontal or a vertical hyperbola. All you do is you find your h and k, nothing changes. Next up, we are going to need our c value. Now our c value is what's going to help us find the location of the foci. So the c value, you simply use the equation c squared equals a squared plus b squared, which is just the Pythagorean theorem. Now I will show you what you want to do with the c value and how that can help you find your foci. So after that, the last thing we are going to need is our asymptotes. Now these are actually different depending on whether it's horizontal or vertical. If it is horizontal and x squared comes first, we are going to have here y is equal to k plus or minus b over a times x minus h. Now, if it happens to be vertical, you will have the same equation with one minor difference. You will have a over b rather than b over a. Everything else is the same. So that is everything you need to know to graph a hyperbola, and you also do need to watch out whether it's horizontal or vertical, as it does change some things. All right, so now that we've got all of that done, let's go ahead and actually graph one here. So let's suppose we have y squared over 16 minus x squared over 25 is equal to 1. So first of all, we can see that y squared comes first, not x squared. Therefore, this graph is going to be vertical, and we will follow this form and this form. All right, so we can go ahead and start finding some things here. The first thing we can find is the center. The center, we obviously know that in this case, it's just 0, 0, because there's no x minus and there's no y minus. It's just x squared and y squared. So we don't have to worry about the center. Lucky for us. Next up, we can find our c value. C squared is equal to a squared plus b squared. So this one is a squared because it comes first. It's the first denominator. And this one is b squared. 16 plus 25 is going to give us 41. And then, of course, we just need to take the square root of each side to find out what c is. So c is equal to the square root of 41, which is approximately, we know 6 times 6 is 36. We know 7 times 7 is 49. So a rough estimate, I'm going to say maybe 6.4-ish, something like that. All right, so then we can go ahead and find our asymptotes. So obviously we know we are going to use this form, y equals k, which is over here. We have no k, therefore k is 0, plus or minus a over b. A squared is 16, so a equals the square root of 16, which is 4. B squared is 25, so b equals just the square root of that, which is 5. So a over b is 4 over 5. 4 over 5 times x minus h. X minus, what is h? We have over here x minus h, x squared. There's no minus anything. H is 0. And then, of course, this will split up into two equations because it is plus or minus. So for one equation, we will get y equals negative 4 over 5x. And for the other equation, we will get y equals positive 4 over 5x. All right, we have everything we need to know for this hyperbola. I'll go ahead and actually erase this so we can start graphing here. Now, I could have given you the coordinates for the foci. However, in my personal opinion and experience, I don't like to graph hyperbolas just using the given formulas for the foci because it will be different depending on where your center is. For example, our center in this case is at 0, 0. However, if you have a center anywhere else, it will be different. So the easiest way, in my opinion, is just finding out what the C value is, and we'll take it from there. I'll show you guys how to do the rest. All right, so let's go ahead and make our x and y axis here. All right, so now that we've got our axes labeled, we can go ahead and start graphing this. So first off, let's start with our center at 0, 0. So that right there is our center. All right, so now that we've got our center, next up, we can label our vertices. Now we didn't actually go ahead and find vertices, but I will show you how to find them using your A and B value. So first of all, you have to realize, is your graph opening vertically or horizontally? This one we know is opening vertically because y squared comes first. So therefore, our coordinates will all go up and down from C, not side to side, only up and down. So therefore, we just have to add some amount to C and also subtract some amount from C. What amount do we add or subtract? That is going to be your A value because you want to take the value that is under y squared because it's vertical. If it were horizontal, you would be using the value under x squared. Anyways, we know that our A is 4. You don't want to look at A squared. You want to look at A. A is 4, which means you go up 1, 2, 3, 4, and you also go down 1, 2, 3, 4. And another reminder, I can't stress this enough, we're going up and down because our graph is vertical. So we have one vertice at 0, 4 and 0, negative 4. Like I said, you could have found this by doing 0, negative a and 0, a. However, don't really recommend it. Anyways, next up, we can graph our foci. For our foci, we need our C value, which we know is roughly 6.4. So once again, this just means you go up 6.4 units, 5, 6.4 right over there. And you go down 6.4 units, so we get right over there. And that is where our foci are at. It's an ugly F. So now we've got everything labeled. The last thing we need are our asymptotes. So y equals negative 4 over 5x, which means we are going to start here and have a negative slope, which means we are going to, let's see, fall 4, run 5. So 1, 2, 3, 4. 1, 2, 3, 4, 5 right there. And then same thing over here. We're going to go 4 and then left 5, 2, 3, 4, 5. So I'm just making some dots for this asymptote so we can go ahead and just connect the dots here and make our asymptote. So that right there is one asymptote of negative 4 over 5x. Now we need to do positive 4 over 5x, which means we rise over run. We rise 4, we run 5, so we're going to go right there. And we do the same thing over here. And then we just connect the dots once again. And we've got our asymptotes. So After you've got your asymptotes labeled, all you need to do is look at where your vertices is at. Our vertices is right there, and we know that our graph is not going to cross through this asymptote or cross through this asymptote. So all you do is you go close to the asymptotes, cross through the vertice, and then go close through the asymptote again. So that is one part of your graph, and then you do the same exact thing over here. And that right there is your graphed hyperbola. We are done. That is everything you need to know about graphing a hyperbola. Now, one thing I would like to go over is foci. So let's use blue for this. For foci, all you do is you take any point that you want on your hyperbola. Let's say we want to take this point. By the way, generally, you don't need to know this, but I do like to explain it because it is good to know what's going on and why you're even finding your foci. But if you don't care to learn about this, you're done at this point. You have everything you need to know to graph a hyperbola. So the distance from one foci to one point on the graph and the distance from another foci to that same exact point on the graph, we'll call this D1 and D2. Pretty much the difference between D1 and D2 will be the same everywhere on this graph. Now, in some cases, D1 will be smaller than D2, so we'll take the absolute value of this. And pretty much any difference that you take, let's say we take it at this point, and this is D1, and now this is D2. The difference between D1 and D2 will be the exact same as the difference between the original D1 and D2. So wherever you take your point on this hyperbola, the difference between D1 and D2 will always be the same. So that is what your foci do on a hyperbola. All right, guys. Well, that was a good lesson on hyperbolas. I hope you guys understand it more now. In the future, if you guys want ACT or SAT help, be sure to visit my website, www.e-ztutoring.com. Thank you guys and have a good day.